So let's quickly go through what all we have learned last week. So last time we wrote a code for a class, and the class name was clock type, and we have written this code in clock type.h file. So while the typing is going on, I will quickly go through what all was there in this file. So it contained public and private members. So in public members we have a special function set time, and now I have imported all the comments also. So these comments are necessary so that whosoever checks this, he comes to know that what is the function of this function. And this set time function is actually there to set the time, and the time is set according to the parameters. And the post condition are here: the HR is equal to hours, MIN is minutes, and SEC is seconds. So the post conditions are written in the comments. So the header file contains all the necessary information. Next we had another public function. The name of the function was getTime, and it had three parameters: hours, minutes, and seconds. And we can see that it is of constant type also, so that it doesn't change the values in hours, minutes, and seconds, because these values are being passed as a reference. So next we had defined another function. The name of the function was print time, and again it is a constant, so it is not going to change any of the member variables of our program. And another function was increment seconds. So the purpose of this function is that whenever this function will be called, it will increase 1 second value of the seconds by 1 second. So it will also check if the seconds have crossed their limit. That means if it is more than 59 seconds, so it is going to set it to 0. So next similarly we will be writing a function for increment minutes, and it will also check the minutes. And if the minutes value is going to increase from 59, then it is going to increase the hour by 1, and it will set the minutes to 0. So next function we are writing increment hours. So it will increment the hours, and of course there are no hours more than 24. So whenever it reaches to 24, it is going to set the hours equal to 0. So now every comment is written, and whosoever will check this file, he comes to know that what is the purpose of each and every function defined in this file. So next we have another function which is of boolean type, and it is equal time, and again it is of constant type, and it will check whether the past values are equal to the one object which is calling this function. So if the past value are equal to the values of this object, it is going to return true, otherwise it is going to return false. So next these functions I am writing the code because it is a quick practice, but I will be explaining in this particular class that clock type, it is the exactly same name which is of our class. So we can have the functions which have the same name, and these are the special function. So we will be discussing it in a bit. We will shift to PowerPoint presentation, and then we will see that. And now you see that this clock type has few parameters. It doesn't return anything, and we can have an overloaded functions of this. Overloaded means that name of the function is the same, but the number of parameters being passed on are different. We have already practiced this. So we have another overloaded function which have no parameters, and name of this function is again clock type. And then if you remember, we had three private members. These are actually those variables, set of three integers which are going to contain the values of hour, minutes and seconds. So this was a definition of our file, our clock type. Now let's write code for another file, which is test clock class.cpp. Here we will be testing what all we have written so far. So if you see that we have started writing it, and the some initial comments about this, then of course we have to include the clock type dot h namespace has to be included, and then our main function where we are starting defining our own objects of clock types. So first one is my clock, and then your clock. Then I have defined three variables, hours, minutes, seconds, each of integer type. And then I am calling one of the function from the clock type on my object my clock dot set time 5430, and this is going to set the values of my clocks accordingly. And then I want to check it. So on line 2 I am saying that what my clock is going to represent, so it will print the time. And on line 5 I will be displaying your clock, and just when we will run you will see what are the outputs for your clock, because I have not set any variables for this. And I give the line 6 also, just keep noting the comments also. And then in the next line have an end line, and then we set the time of your clock. So first we will observe that without setting any time what you got, and now we will check that what is the value when we set your clock with these values. So after setting your clock, we will be again printing the results. And then when we see the results we'll just give a break. And let's go to the next thing. Then that is the compare my clock and your clock. So if the values set here we have set 5:45:16, and before I think this was something different, but it will compare if both are equal. So we will put on the screen a message that both times are equal. Otherwise we will say that both clocks are not equal. So we will be using if else command, and that's how we are comparing it. So next on the line 16 we should take the input from the user, and it should be hours, minutes and seconds. And whatsoever the user will input we will just store it in our three variables, and then we'll start manipulating with these three variables with our objects. So now we set the time of my clock using the values of the variables of hours, minutes and seconds. So it is just simple. So my clock dot set time, and then I will pass these three variables, and then I will print that what is the values when I set these values which have been given by the user, and I will print it on the screen. So we will see that. And after this testing we will go for another test, and that is if we increment by 1 second what is going to happen. So we already implemented the logic for this. If you are interested you must see the last lectures video, and then you will come to know what logic we have increment used for incrementing the second. So once we increment the seconds our clock will be again represented or printed on the screen, and we will check whether this logic of incrementing 1 second, and then if it is 59 seconds, so it should be 0 and minute should be increased. So we will be checking it once our program is complete. So now we retrieve the hours, minutes and seconds once we have incremented, and then everything I am doing with the my clock. Okay, so my clock now get times after incrementing. So we'll just print the values, and then in the line 28 we will finally print what is the value of hours, minutes and second which we have stored in this particular program. So then we will return 0 and end our main function, and let's see what happens when we try to compile it. Okay, now let's clean this folder and just keep the necessary files in the folder. So I already compiled it and run this program, and you see once my clock was printed, so it printed exactly what we have set the time. But when the time came and your clock was printed, it is printing 63,500, and I don't know how much is that. Why? Because your clock variable was not set to any, and it has taken any memory, anything which was available at that particular memory when that object was created. So we can just uh, see that my clock was printed, and then your clock is printed now. After setting, your clock has become 5:45:16, and now if we run this program once again, and you can say that, and since both the values are not equal, so it is printing that two times are not equal. And now let us put input 12 23 45. You see everything it has printed as 12 23 45, and then when we increment it by 1 second, it becomes 12 23 46, and it has printed the values. So let's run it once again and see if we give some other values to the hours, minute and second. For example, it should include 23 59 59, so everything should change now. So once the uh, we enter these values, so the entered value is 23 59 59, but once we increment it by 1 second, so the 59 second becomes 00, and 1 minute is incremented, and when it was incremented, it becomes accordingly. So the time became 000000. So far we have in order to run this program, I just commented out these two functions which we defined while creating this, and you see that the name of these functions are exactly the same as of. So the name of the function is exactly same. I have just commented out so that our program was running without these two functions, and what we are covering now onward is how, what does this mean that it has the same functions name. So this brings us to the topic of constructors. We have already seen what these constructors look like. They are just functions and they belongs to some class, and name of these functions are just the same what the name of the class is. So once we define these constructors, so these constructors basically guarantee that all member variables of a class are initialized. So we have seen two types of constructors, one with the parameter and one without parameter. So here, in order to run the program, I already commented out these two constructors. So this one is with parameter, and second one, the overloaded function of the same type, only except that it does not have any parameter list, is without parameters. So these without parameters, they are also known as default constructors, and we have already observed that name of constructor are name of classes. In fact, one more thing to note is that constructor has no type. Unlike other functions, every function has boolean, void, or these do not have any return types. So a class can have more than one constructor, as we have seen. Each must have a different formal parameter list. Constructor execute automatically when a class object enters its scope. They cannot be called like other functions. Which constructor executes, it depends on the type of values that have been passed to the class object when the class object is declared. So a constructor is automatically executed when a class variable is declared. Because a class may have more than one constructor, one can invoke a specific constructor. To invoke the default constructor just by declaring an object of a class type, it automatically invokes the default constructor. So example we have already seen in our program. And if we have to set the values using another constructor, so in that particular case, we define that as class name followed by the class object name, and then we pass the different arguments, and by this way we invoke a constructor which have the parameters. Number and type of argument should match the formal parameters of one of the constructor. So it is just applicable to all functions. If we do not pass the correct number of arguments, and then that function is not going to respond, and computer program will give an error. And although the compiler tries to convert and invokes the best match type of constructor, but this will create an ambiguity, and that may lead to an compile time error. A constructor can have a default parameters. Rule for declaring formal parameters are the same as for declaring default formal parameters in a function, like we have used in set times in our programs when we were testing that program. So similarly, we can declare the parameters or the formal parameters at the same as of declaring default formal parameters in a function. Actual parameters are passed according to same rules for the function. A constructor with no parameters or with all default parameters. if a class has no constructor, C++ provides the default constructor. So whenever uh, we do not declare any constructor by ourselves, so C++ will provide one from its own side. However, they cannot be initialized. They are declared but still uninitialized. If a class includes constructors with parameters but not the default constructor, C++ in this case will not provide the default constructor. And one more important thing, that C++ 11 and onward versions, they allow member initialization in class declaration. So these are known as inline initialization, and these can eliminate the need for a default constructor. Not all compilers recognize this feature. So we have to, for the sake of our course, we have to follow declaring the default and um, constructor with some parameters. So same like other data types, we can generate an array of class types. So in this particular case, we have defined 100 objects of clock types, and each object of that clock types is just like an array of any other data type, but these contains these private members variables as its data, and we can access if we want that arrival time implies arrival type. This is something which we have declared, so it is noting hour, minute and second for the 49th employee. Similarly, here it is will be a recording for the employee number 1, and if we have declared the 100 elements, so we can save the 100, we can access that kind of if data. We want that arrival time. So if you understand what is constructor, so constructor is basically what it is doing, it is initializing the member variables, and a set of memory is not just left without anything being in there. So we give some values to those, and that memory is specifically used for this class. So once we are finished with using of that memory, the C++ give you a control to destroy that memory, and for that we use destructor. And destructor syntax is very simple. In any place with this sign and name of class, the destructor is applied. So this wave sign clock type parenthesis colon will destroy whatsoever has been created with using this class type. So a class can have only one destructor. The destructor has no parameters because it is just a command to delete the memory and free that memory for some other use. So destructor automatically executes when the class object goes out of scope. So even if you have forgotten to write this, if your program determines that your class is no more required, so it will automatically call this, and uh, the memory will be freed. This is known as memory management. Next, we observe abstract data and classes and abstract data types. So in our example, we have already used a header file where the design details were there, and we separated a logical properties from the implementation details, as implementation details were written in some other files. So this is what all abstraction is, that we don't mix the design details with the implementation details. So we can have our own logic to implement any design and not to pass on the code for that particular implementation to other users, because that can be converted simply into the libraries. However, if you want that this code should be used by the others, so they are able to see the details, design details, that what kind of functions your object can have. So this is what the abstraction is, separating the both layers, the design details separately and implementation details separately. So these abstraction can also be applied to data, and abstract data type are those which separates the logical properties from the implementation detail. So I've already discussed as little difference between struct versus a class. So let's see what this slide says, that by default member of structs are public. Private specifier can be used in a struct to make a member private. So you specifically, if you want that some member of the struct should be private, you declare it separately. But by default, the members of class are private in contrast to the struct. So if you want something to be public, so you have to specifically define in the classes. Classes and structs have the same capabilities. In C++, the definition of a struct was expanded to include member function, constructor, and destructor. So everything which a class can do is easily done by a struct. So if all member variables of a class are public and there are no member functions, so we may use a struct, but this struct is only specific to C++. If you familiarize yourself with the class, so classes are equally applicable, almost with a little difference in the syntax, in Java or in C#. So it is your own choice if you want to use struct or you want to use classes in this particular case when they are public. But I suggest that using classes is instead of remembering two keywords and going following rules for these two, we can just see the class or more generic type of struct. So struct, everything is public, but classes, we have this capability which is known as information hiding, because all the information by default is private. So information hiding is the hiding the detail of the operation on the data. So interface header file contains the specification details with the file extension .h. You have already seen this. And implementation file contains the implementation details with the file extension, that is .cpp. In header files, include function prototypes and comments that briefly describes the functions, specify precondition and or post condition. So once I showed you while writing the code for header file in class, let me see, it is available here. So we have all these precondition and post condition written as a comments, so that everything is uh, well transparent as far as this design detail is concerned. Okay, the implementation details will be compiled, and this maybe if you are passing it to somebody else, so they will not be knowing exactly until and unless they decode it, but this thing, it should be available to them, and that is what it is saying. In header file, include function prototypes and comments that briefly describe the function, specify precondition and post conditions. Implementation file must include header file via include statement, and in include statement, user defined header files are enclosed in double quotes, unlike using the angular brackets, and system provided header files are enclosed between angular brackets. Precondition is a statement specifying the condition that must be true before the function is called. So you must indicate that particular information in your comments in a header file. And similarly, the post conditions statement specify what is true after the function call is completed. To use an object in a program, the program must be able to access the implementation. Okay, so if you have only header file and passed it to somebody else, or you are trying to use only the header file in your one of the file and you compiles only one file, it is not going to work. So if you see, when I compile the code, I have actually compiled both the files, the clock type implementation and test clock class. So both of these have been compiled using this command. And then I got this clock.exe as my output. And that's what I demonstrated. So Visual C++ 2012 Express, Visual Studio 2012 and C++ Builder put the editor, compiler and linker into a package. So I was using Visual Studio Code, so I have to write the command. But if you are using Visual C++ or Visual Studio, Microsoft Visual Studio, then everything is comes in one package, and you just give the command Control F5 and it compiles everything which is linked and give an output file. But in our particular case where we used Visual Studio Code, so I have to give that command. One more important thing is that in a class, we can have static members. So what does the static mean? That any member in a class cannot be accessed directly until and unless we create an object of that. So we have to declare an object of that class, and then we can access any member or variable through that object. But what if you don't want that such and such function should not use an object and should be available all the time? So we can declare that particular function or a variable with the keyword static. So a public static function or member of a class can be accessed using the class name and the scope resolution operator, that is the two colons, and it is going to work. So static members variables of a class exist even no object of that class type exists. Multiple objects of a class each have their own copy of non-static member variables. All objects of a class share any static member of the class. So these are simple uh, understanding about the static members. So in order to make you understand what all is I have said about the constructors, so I have commented out from my clock type.h file and the clock type, which are basically constructor in this particular case, and I must implement this in the implementation file. So I've already code and I will just paste it. So this is the code for the constructor. So it is just a simple function, and you have seen that before this we have used this set time function, and the code for this, because it is also used to set these values as a these values for our HR, MIN and SEC variables. So same thing this constructor is also doing. So what the difference is that in that particular case we have to call that function. The name of that function was set time. So but in case when we want to use this, so let's save this and let's implement this, test it here. So before uh, exiting, so if I declare clock type PC, okay, this is just PCs, and then here uh, while declaring it, I can pass 12, 23, 45 as member, and here I can just I will just cut and paste this, and so this should be line 29. 29, and what is doing after incrementing? No, it is what is we are actually initialized using constructor. Okay, so this is not required. We can just place it here, and this is going to print this line 29. So here I change, instead of my clock, I will just replace it with the PC. And of course it is giving error because we have not put this semicolon here. So the TC has been, this TC is just test clock, and this has been initialized using constructor. Okay, so I save it, and I will just recompile everything so that this code, maybe I can, if it permits me here. So I deleted that clock.exe. So now I've given this command, and when I enter, you will see that a new clock.exe will appear here. So has it not worked? So yeah, it has one error. Clock type. Okay, right. So far we have implemented only one type of, whereas here we have defined this clock type. So let's define this also, implement this also, details of this. So clock type, and then clock type, and here is the implementation detail. So what we want, that in this particular case we just say min uh, r is equal to 0, and min is equal to 0, and sec is equal to 0. Okay, so now our all constructors are initialized. So I save it, and let's clear everything here and make a new terminal. And I will write that command. So G++ is basically the compiler command to compile it, and then we give the output file as clock.exe, and whatever we have to pass as a um, compiling files, so we just write the name of those files. So we have two cpp files, so clock type imp.cpp and test clock class.cpp. so if there are no spelling mistake in the name, so I just enter the command, and you will see here the clock.exe will appear. So good. So clock.exe is here. So since it is a big program, so I will run from. So here is, this is the clock exe. So I run this program, and I just, if I just pass 78, let's see what happens. So you see 78 has been converted to 00, and by after incrementing it has become 01. Okay. So line 20 are 12 minutes 56. Okay. So here our format is not good. Line 29, which we just initialized our own, and we passed 12:23:45, and it has given this code. So let's improve it further. So anyway, you can observe that we just used constructor to initialize these values, and it has worked. So we will now use the second, because in this constructor was the one which had the parameters. So now we will use a default constructor, and you will see that what values are then set. Okay, so let's exit this program, come to here, and we must give okay. So till here it was initialized using constructor, let's say with parameters, and we passed parameter as 12, 34, and 45, right? So let's make one more object of this. So let's call block type this is tc2, and we just don't pass any parameters to it. And now let's see, and this will be line 30, line 30. So initialized using constructor without parameters. Okay, and here instead of TC we say TC2. Yeah, we must say C out end line, and of course an end line here also. This is our line 30. Okay, now I save it and I recompile my program. So the clock.exe has been updated. Let's go to, so enter the hours, minutes and seconds. So this time I put 23, 59, 59. So you see this was my clock's value 23, 59, 59. When I incremented by 1 second, so the clock value becomes 0, 0, 0. Then my variables also, which because I am reading my variables from this object. So now in this line I initialized constructor with parameters 12, 34, 45, and it printed this. Okay, I will just correct this also. And then I had this without parameters, and then it printed uh, this one. So its function is good. Just let me add something so that it becomes more clear. So end line and C out TC2 and end line. Perfect. So everything is here now. So we will just rerun. So it must have updated this file. So let's run it. So there are 23, 59, 59, and so in line 29, the TC has been initialized using constructed with parameters 12, 34, 45. So TC's value are 12, 34, 45. And then TC2 has been initialized constructed without parameters. So in the default values, if you see here, the hours, minutes and 0 seconds are put 0. So the value comes out to be 0. So this brings me to the end of this lecture. So I hope you have learned something out of it. So I will be recording one more video in which we will be going through um, complete review of our course, and that may give you some confidence that what all you have learned. Video in which we will be going through um, complete review of our course.